so let's do it like we did last time. We'll go through the lecture and then I'll leave a bit of room for questions. And I'll put a thing on Piazza for questions. In fact, yeah. All right, so just a few things about inheritance, super and subclass. So as you know, it's okay if you have an object from the superclass that from the subclass. I'm sorry, the more specialized one. Then you can move it into a variable whose type is less specialized. So a bank account can hold your savings account, and even a variable of type object can hold your savings account. And so what happens here is, of course, that we have three object references, college fund, an account, an object, and they all point to the same object. The only difference is that the second and the third one, they don't know as much about the object as the first one does. The first reference knows it's a savings account, and the third one just knows it's some object. Well, just about anything is an object, so that's not knowing very much at all. And so the question is, why would you ever want to know less than you can? So what's the point in making it so that like if we look at the bank account here, that the bank account, why do we do this? Why do we declare it as a bank account and not as a savings account? Obviously, there's a disadvantage. So if you look at this code over here, an account, remember, is a bank account. I can deposit on it, but now I can't call add interest on it, even though what I'm having is a savings account, and I should be able to do it. So why would anyone want to know less about an object than they can? So in this example, it doesn't look like ignorance would be bliss, but it turns out it is. And so the reason is it lets you reuse code that you could not otherwise write. So look at the transfer method. In the transfer method, I want to transfer from my current account to some other account. And here I'm saying bank account because I want to be able to transfer into any old bank account, doesn't matter which. And when I call it with a specific account, it may well happen that I pass in a savings account, but this method will not know. So in general, when you write a more generic method, one that can work with different kinds of subclasses, then this conversion to superclasses really helps you out. But it's not something that one normally has to think about a lot. That generally you want to specify the most general type that you can that makes your code as flexible as possible. Now, occasionally, you have to do it the other way around. You have something that was handed to you and maybe as an object. Someone said, here, have this object. But you just know that it was actually a bank account, and then you can cast it back. And of course, the cast is dangerous. If you're wrong, if it was actually a watermelon and you try to cast it to a bank account, as your program runs, as your program tries to execute this expression, it's then going to throw an exception and die. So you can prevent that. You can use an instance of test. So you can, before you make the cast, you can make sure it's safe. You can say, is it in fact true that an object is a bank account? And then instance of returns true. Otherwise, instance of returns false. So if it returns true, then we can safely make the cast. Now, ever so often, one needs to do this. And you've already seen a couple of situations, like when you implement comparable for the comparable interface and the comparator method. You get an object, you have to cast the object back. That's just life. But sometimes one finds people who say, oh, this is great. I don't actually have to ever use types. I make everything as an object, and only in the last minute I make type inquiry, and then I do the casting. And that turns out to be a fragile style of programming that you shouldn't be doing. The types are basically there to help you out, so you shouldn't try to defeat them. So if you find yourself doing casting, doing instance of tests, always ask yourself, was it avoidable, or is it just unavoidable because someone just gave you this raw object? So try not to do this. All right. Let's have a quick clicker question to see that everyone is awake. Let's set it up. Yes. New post to poll. All right. I'll look at it in the next paper. Okay, let's have a peek here. 18 lousy votes. And only have 18 lousy votes. Okay, well, whatever. Okay, how many votes do I have? Okay, so maybe next time what you guys can do is log into your laptop before everything starts. Seven. Six. All right, so I have 70. I'll live with 70. So let's see. So the vast majority of people said entirely correctly, this is so that you can call it with any type of bank account. Okay, so C and D are almost the same because in the context of the book, we only had two separate kinds of bank accounts, right? We only had savings and checking. But maybe someone is going to come up with some other kind of bank account in the future, you know, some offshore account or something. And then transfer will still work with any kind of bank account that anyone will come up with in the future. All right, good. So we already mentioned the class object. It's the superclass of all other classes now or in the future. Anytime that you don't say something extends something, it automatically extends object. So what's the point of having such a class? Oops. It has a few useful methods. I thought I had the picture here. So it has a few useful methods that make sense for every object. One of them is toString, the other one is equals, as you already know from the homework description. So toString is useful for debugging. It gives a string representation of the object. You've already seen it last semester. When you print a rectangle, it gives you this description, java.awt.rectangle, then the brackets, and then the values of all of the fields. That's kind of the standard form that toString is expected to look like. So unless you have a great reason to do it otherwise, you should always make toString look just like this. Name of the class, angle brackets, names and values of the fields. So toString gets a bit of special handling that if you use the plus operator and either to the left or to the right is a string, then whatever is on the other side is automatically hit with toString. So in this case, that means box equals plus box dot toString. The dot toString is supplied by the compiler. They're very useful. So object.toString is defined. So it has to be defined as something, of course. And the way it's defined is to print the name of the class, followed by an @ sign, followed by what's called the hash code. We're going to learn what the hash code is in a few weeks. Right now, you can think of it as a pretty random-looking code. It's somewhat related to where the object is in memory, but it could also be something different if you actually define what the hash code is. If few of you noticed this in the lab on Tuesday, some people came to me and said, look, my computer is broken. It printed item at, and then something really weird looking. And so the reason it did that is it called toString on the item because you passed the item to system.out.println, and that just calls toString on an object so that it can print it. And because you didn't supply your own toString method, you didn't know that you were supposed to, or how to do that, it inherited the one from object. So it called object toString, which prints the name of the class, followed by this random looking code. So that's just what always happens when you don't overload, when you don't override toString. So you want to override toString, and here's how. You just print the name of the class, the angle bracket, all of the fields, and their values. Except there's actually a better way to do that, and that's what you really should be doing. You should be prepared for inheritance, because someone might take your class later and extend it. And so if you print bank account, and then later they extend it, they would like it to show us checking account or savings account or whatever it is. And so you can help them out by calling getClass.getName. So getClass is another method of the object class, and it gets an object of type class that can do other things that we don't care about. We just want to get the name of the class. So you can just remember that getClass.getName gets you the name of the current class as a string. And so we want to do that and then concatenate it with this stuff. So then in the subclass, what we can do is we can just call super.toString, which then prints savings account in this case, the balance, and then afterward we tack on the subclass fields. Notice that there's now two pairs of brackets, one for the superclass fields and one for the subclass fields, which brings us to this clicker question. All right. What does it print? You have the code of the methods on the previous slide. Okay, speeding up here. All right, so how come I only have 22? 31? Okay, I want more answers. Huh? Yeah, hi, this is Kai. I'm coming in and watching. I called on Tuesday, projected failing, and it just failed again. Horse like HORST maker. Yeah. Washington Square 1. Yeah. Yeah. it just goes off. It just turns itself off. It is. Yeah, yeah. All right.
And here's why. The employees are sleep train owners, so they are totally committed to make your purchase perfect.
And they'll guarantee anytime they'll beat anybody's price by at least 5%.
Ever. Okay, well, looks like we're back in business. Hello? Yeah, okay, well, it's come back on. Yeah. But I really appreciate if you could come by and check out why it's doing it. Yeah. No. Okay, thanks. Okay. All right. So yeah, so this one was apparently not that hard either. So I did manage to fool a few people with C, and I was hoping that I would. See, C is kind of what you want, right? But you can't get it, because in general, you must call superdot to a string, because in general, some of the fields in the superclass will be private, and only the superclass can print them. So in general, you don't have access to every single field in a class, and so you must rely on superdot to string to print it. Well, superdot to string, what's it going to do? It can print your class name by calling get class get name, so that'll dynamically print the correct class name. Then it prints an opening bracket. Then it prints its fields, and then it's going to print that closing bracket. What else is it going to do? So anytime that you use inheritance, you're going to be forced into this format where you have a closing bracket and then another opening bracket. It's just life. All right. Now overriding the equals method. So equals is a little trickier than toString. Because it takes two parameters. So it takes the thing and the thing that you compare it with. It's just the same thing. If you looked in the book about measurable, measurable is pretty easy. And then comparable is harder because comparable takes two parameters, the two things that are being compared with. So equals is the same situation. So equals tests whether two objects have the same contents. They may be different objects. So in this case here, I have two coin objects that just have the same contents. And be sure not to confuse it with equal equal. I have it here? Yes. The equal equal tests whether two object references point to the exact same object. Of course, when two objects are equal equal, then they are also equal, but the other way around may not hold. You may have objects with the same content in different places. So how do you write equal? Well, first off, notice that you're being handed an object for the other one, because that's the signature in the object superclass. One can't change that. So you need to cast it. So over here we do the cast. And once you do the cast, then you can compare the fields pretty much like you do in comparative, but it's actually easier. In comparative, you have to worry about, if you have multiple fields, which one is more important to you. With equals, they're all equally important. They just all need to match. So here we check whether name equals other name. We check whether value equals other value. The only minor piece of intelligence that you need is to realize that when you have numbers, you use equal equal to compare them. When you have objects, you use, again, equals to compare them. So a basic equals is very easy. All right, and I have a clicker question. Okay, let's see how we're doing. 19. And while you do that, I'm going to do some housekeeping.